when I was investigating this a while ago, I guess about a year ago, it's been just over a year before I finally just had the eureka, I guess not moment, but it was a period of days, I think. But one of the things that I feverishly searched after was considering the implications if it is this way and the globe is a lie, then Antarctica is going to seal the deal for me. And when I looked at it, basically everything becomes sketchy south of 60 degrees latitude, and that really sealed the deal for me. And then on Google Earth, it's even more so obvious. So yeah, I got off a little bit on a tangent, but it's
that's okay.
Hey Bob, I'll share my
about
screen.
Maps. That's a deal breaker for me. I don't see how anybody can accept that in 2018 that we don't have a globe, a photographic model that's without problems, without dark areas or sketchy pivot points and flatness to it, and on a certain zoom level.
Well, and to your point on Antarctica, I agree. Antarctica introduces some really major problems for the globe because, if you think back to Admiral Byrd, that was in like the 40s or the 50s or whatever. We've had the ability to go down there and check it out. And according to them, there's all sorts of stuff that the modern world would really want to get their hands on, like, corporations and governments of the world really would like untapped natural resources where there's no sort of land dispute or anything like that. And yet, decades later, half a century and plus later, almost 100 years later, we're getting there, right? Still, it's illegal for corporations to go and tap the natural resources of Antarctica. And we've been through energy crises and this whole thing with, the oil crises and just all of the pollution, the fracking, just everything that we're doing right in our own backyards to get at this hard to get energy when Antarctica is just sitting right there the entire time. That makes absolutely no sense whatsoever. Just from a practical sort of corporate capitalistic frame of reference, it makes no sense that Antarctica is still sitting there untapped. And yet we still have this very antiquated sort of just ridiculous Antarctica treaty, which forces people to essentially not be able to free roam and do anything of value in the Antarctic. So yeah, very fishy indeed.
And another revelation. I don't know if you guys saw this, but or if you know it, if you haven't considered it, how many people live north of the Arctic Circle versus south of the Antarctic Circle?
Yeah, that's huge.
Yeah, and life in general, just plants and animal too.
Yeah, like a tree population. Those are two examples. So what I found looking into it, north of the Antarctic Circle, you have a year-round population of about 4 million. Now, Wikipedia says only 4 million because of the harsh climate. Okay, so the Earth being a globe where you have equal insolation, incoming solar radiation from the sun on north and south, logically you should have about roughly 4 million people living south of the Antarctic Circle, when in fact that number is actually 0. And that really blew my mind. And as far as trees, I'm not aware. I mean, I haven't fully researched into it, but I'm not aware of a single tree growing south of the Antarctic Circle. But north of the Antarctic Circle, of course, you have forests and wildlife. You're comparing. There are about, I think I found 5 animals. Penguins, albatross,
insects,
seals, whales. Yeah, I don't think there are really insects. It's a completely lopsided comparison when you make it, which totally supports the idea that Flat Earth has of, okay, we have a sun going around the circle, so you have a lot more solar radiation towards the center of the circle than you do on the outside. And that bears out in almost every measure of latitude.
Right. One other huge, one other huge incongruity, I just wanted to throw this in there, is that, of course, during our wintertime or the Antarctic summer, the Earth is, in the heliocentric model, technically, 30 Earth diameters, Jaron, closer to the sun?
Mm-hmm. Yep. Wait, which one? You're talking about when it's way more than that. 300.
300 Earth diameter. Huge number. 400
millions of miles, right?
Yeah, closer to the sun, and that to me is one of the biggest disconnects ever. It should be somewhat tropical down there compared to the Arctic Circle.
Right.
Right. It seems like they had to put it that way because obviously the Antarctic winter is way more harsh and way colder than the Arctic winter. So they couldn't have it where the Earth was closer to the sun during the Antarctic summer rather, or vice versa, because that would make even less sense. Does that make sense?
But
like they have to have it right.
It is.
Well, no, during the northern winter, they have the sun closer than in the southern winter, right?
Correct.
Right.
Yeah. Right. So what I'm saying is that they had, because at some point they introduced the idea of off-centered ellipsis orbital planes or whatever, and so they have to have a point where the sun is closer to the Earth. And so to me, logically, it makes sense that they would have the sun closer to the Earth in the northern winter than in the southern winter.
Well, the reason I think they did that is because of observations. Because observationally, the sun is its angular size is larger during the southern summer. So I mean, basically, they couldn't get away with saying that it's larger but further. So they have.
Oh, okay. So and that's as a rule.
Yeah, it always is. Yeah, I think it's I don't know if it's like 2 degrees or what it is. It's 51 to 53 or 54. Yeah.
Well, yeah. I mean, the apparent angular size of the sun and the moon does change. I just didn't. I was unaware that as a rule it was larger in the southern winter. So wow, interesting.
No.
In the southern
summer. Yeah.
Right. Well, yeah. Gotcha. You know what I meant.
Gets a little bit confusing, I know.
And
this whole
the seasons are equally. Oh, sorry. Well, the seasons are equally in length, but they shouldn't be. If it's an elliptical orbit, it accelerates when it's closer, and then it slows down when it's further out. But I don't think they've addressed that. I'm not aware of it if they have, but it's just another complication to their model.
Yeah, the whole equal area and equal time nonsense, because if you draw out that orbit and you put the focus at the sun there, well, the way that we're going the slowest is when we're far away from it, and that's the longest path is supposed to be equal time with the one that we're going fastest on the small path, which makes no sense at all. But they use it to say, oh, that sweeps equal area, and then they figure out the areas and say that it's equally sweeping areas, even though that makes no sense because you'd have to change the speed.
Oh, that's really interesting, because that would explain. Okay, so many people have probably seen the video I did back in 2015 on how the 4 seasons work. That video came as a result of me trying to figure out on the globe, how does the 24-hour sun work? And so I used Stellarium, which is heliocentric globe-based software, and you can put your location of observation wherever you want. So I put it in Antarctica. I think it was in the Ross Ice Shelf area or somewhere like that, wherever you supposedly can see 24-hour sun. So I put my camera there, and then I pulled it. You can adjust the camera and the type of lens you use, and you can adjust it such that you can either look at each cardinal point, north, south, east, or west, or in the case of what I did, I pulled the camera into the Earth and used the fisheye lens setting so that I could see all 4 cardinal points at the same time. And then I just got rid of the ground plane and removed the stars. So the only thing I could see then is the sun and moon. And I set it to record for a whole year real fast and recorded that. And this software, heliocentric globe-based software, showed the sun and moon speeding up and slowing down as it was creating these circles. And I just thought, well, geez, I wonder what that would look like on the flat Earth map, on the AE map. So I just superimposed it on that, and then I just flipped it horizontally because I'm looking down instead of looking up. And it actually showed the sun and moon going between the tropics and slowing down when it gets in the northern so-called hemisphere and speeding up when it gets in the southern hemisphere. So you're saying that is explained by us supposedly getting closer to the sun in their model? And and so that's how they explain the illusion?
Yeah, let me, if you bring it up, I'll share my screen and show you what I mean.
Okay.
Hopefully you're talking about the same thing. Hopefully you can see this. Share screen. So you see my little drawing thing here?
Yep, we see it. And we're
okay,
presenting.
So basically you're doing this this path here, and this would be during the southern summer, right? And so it's a smaller arc, but you're also going faster, and yet you're supposed to cross the same amount of area in the same time that we do our summer, which is the longer path and the slower.
Wow.
So it makes absolutely no sense that you would sweep those, and then you have your spring and fall here. But yeah, I mean, this is much longer part of the ellipse, and we're going much slower. But yet they say you sweep equal area. That's, I think, Kepler's second law. I'm not sure which one. That you sweep.
Second law.
Yeah, equal area and equal time. So you have to do.
Well, and the reason that this becomes even more absurd is when you put the sun in motion as it is.
Right.
But it's not represented here. But when you put the sun in motion, you get these long sort of corkscrew patterns where half of it is necessarily going to be this very long arc representing the Earth traveling just a mind-boggling distance through space with the sun. And then the next part of that arc where the Earth's going in the opposite direction, essentially as that solar frame of reference, then you get these really tight parts of the corkscrew where hardly any distance is traversed because the sun's motion is doing a lot of that work, right? You get the same thing with all orbital mechanics, like even with the moon. It's just a huge problem. But there's another one, and that's not even figuring in the fact that the sun's supposedly in motion in their model, which makes it just absurd.
Yeah.
And
and they had to make a choice. They had to choose what they were going to explain. So what they chose is to explain the motion of the sun in the sky that we observe by saying that the Earth is moving faster because it's closer in the southern hemisphere summertime.
So, but
to do
in that
that,
model,
it has to be closer. And if it's
can I
closer,
share the screen, Bob?
Hang on a second here. Continue.
Okay. I'm almost through with the point. If it's closer, then that makes another reason that the continent of Antarctica should be a tropical destination for us.
Right. That's what I was going to say, because when it's in that drawing that Jaron has there, the Earth would be tilting off to the top right, because we would be in wintertime. And so, yeah,
right.
when we're in
the axial tilt.
The axial tilt, the Earth would be pointing up to the upper right corner, such that that's why it's summertime in the so-called southern hemisphere. But you're right. I mean, how many million miles closer? It should be a tropical paradise.
Yeah, it's 3 million miles closer, which I think is 300 Earth diameters. I'm not sure exactly. But on top of that, you've got 24 hours
square law.
Too. Yeah, exactly.
It makes they would be on fire.
Yeah.
Well, it would be less than 1% of the entire one radius, though, or I mean, less than 5% rather.
Yeah, less than 5%. But I think
so that diagram is a little bit skewed. I mean, not that you're going to get it perfect. I mean, I see that you're getting a point across, but just playing devil's advocate, we're talking about a relatively small lopsidedness to it, right?
Oh, you mean the entire track there, the ellipse or whatever?
Right. I mean, so 3 million miles closer is a lot of miles, but it's not a lot of 93 million miles.
No, but I mean, when you think about 376 Earth diameters, you're right. It would be more like here. But I think the crazy part is you've got a frozen tundra down there that can't recover.
Oh, yeah. It should be boiling, right?
Yeah, it gets 24-hour sun. It's not like it's day and night there. During the summer, they're getting their summer, of course. They're getting 24 hours of sun, and that's why I've always questioned, people. You think it's a fake sun down there? I'm just saying that it's pretty weird that the sun is closer and is right there 24 hours a day, and yet it won't melt any of that ice. Well, what's the reason for that?
Yeah, so like the whole globe Earth argument for the seasons is that the equator gets the most mean sunlight at the best angle. But according to that logic, I totally agree. I've thought about this for years, that during the summer, the southern hemisphere should just be absolutely boiling.
And I reject the premise of the axial tilt completely in its entirety to begin with.
Right.
Well, you could
can't
just place
have
it
something lay on. You can't have it spinning on an axis to the side and have it revolve around something else. Mechanically speaking, it will never happen. You can't demonstrate it in a lab or in any other way other than drawing pictures. Is the only way.
So what do? We just give that 23.5% to the 23.5 degrees to the sun? Is that how it's rectified? I mean, basically, then we're saying that the sun is on a orbital tilt or a plane inclined 23.5 degrees to the Earth. Is that how it would be corrected?
I don't know. Well, I don't know how they really ever explained it. It's just something I've seen my whole life, and it never sat well with me. And it's one of the euphoric things of dispensing with the whole model that they've created, was that ever since I was a child, that axial tilt, the revolving at an angle like that all the way around the sun, I reject that premise.
Well, they claim that the Earth is like a gyroscope, of course, but then of course on the other hand they'll say that it shouldn't generate any centrifugal force either. But so they get away with it by saying that it's behaving like a gyroscope, holds its rigidity in space. But in order to even begin to subscribe to any of that, you have to go with the assumption that the universe is an infinite vacuum. You have to go with the assumption of gravity. You have to go with the assumption that the Earth is a sphere as a base for all of that stuff. And frankly, none of that stuff exists in reality. And you're right, you can't demonstrate even something as simple as gravity in a lab. Mass does not attract mass, and yet everyone in scientific believes that it does for some reason.
Yeah. Well, and my point is, like, if you have an attractive force, then the heavier side of the sphere that's spinning is going to locate towards the sun. You're going to have it spinning at a different. You're going to have the axial tilt is going to match up with the axis of revolution. But the way they have it at 23.5 degrees, and then it maintains and it goes around. They call it the wobble, and it's wobbling at 365.25 days every year, perfectly matched. And then they say, well, it's not perfectly matched. There's this axial precession that takes place over 26,000 years or something like that. Of course, it's such a long time frame that you can't observe that.
Well, you should, though.
I've rejected that premise,
Yeah, you should observe it, like especially with Polaris, because if you break down that 26,000-year precession, you get 1 degree every 72 years, half a degree over 36 years, quarter of a degree in 18 years. That doesn't sound like a lot, but if you're talking about our axial alignment in air quotes with Polaris, we shouldn't have the same North Star for more than a couple decades at the most.
Right.
And yet we've had Polaris for all of recorded history, and somehow all of astronomers overlook this. I don't get it.
Yeah.